Hello learner. Today we are going to learn about basic intensity transforms in image processing. So we were talking about images, different types of images. So on images, basic gray level intensity transform functions are the following. The first one is image negatives, another one is logarithmic transformation, the third one being power law transformation, and the fourth one being piecewise linear transformations. So now the fourth one, piecewise linear transformations, this can be bifurcated into further groups, into further transforms, which we'll be studying in our upcoming videos. So let's start by understanding what is image negative transform and how to apply image negative transform on an image. So as we saw, there are different types of images. The first one being your binary image, in which the values are either 0 and either 1. This transform we'll apply today on a grayscale image. As the first slide said, grayscale transformations. So a gray image is one in which the values vary between 0 to L minus 1. L being the level in the image. In the last presentation, we understood how L is calculated. So L is calculated with the formula L is equals to 2 raised to power BPP. In this particular case, our given image, I'll tell you that the L here is 3, and hence the maximum value for white, which will represent white color, here is 7. So 0 being the black value and 7 is basically representing the value for the white color. So now coming back to your image negative transform. So levels play an important role, hence we discuss the same. So L is equals to 2 raised to power BPP. In this case, it is given that the BPP is 3 and this is the image. So it is a 3 cross 4, it's a 4 cross 3 image, 4 rows, and it has 3 columns. So each pixel, 7 is a pixel, 6 is a pixel, 5 is a pixel. Each pixel will be represented by R, and each pixel for the given image will be represented by R, and each pixel for the new image will be represented here by S. We don't know what is the output pixel for the new image, because we are yet to apply the transform. So this is the one of the basic transformations. So basically it says TS is equals to, the formula says TS, that is the value of new pixel. Value of each new pixel is depending on the old pixel. It's a linear transformation. It says it is L minus 1 minus R. Here L minus 1 in basic terminology is basically representation of the white color pixel. So L is 2 raised to power BPP. Here BPP is 3, hence L is 8, and hence here the formula for us will become TS is equals to 7 minus R. So to create a negative of an image, we basically invert the values by subtracting each pixel from the maximum intensity. Maximum intensity means the intensity which is representing the white color. We'll subtract the current pixel from that maximum value and we'll get the new pixel for the output image. So the output image size will be same as the given image. I'll show you an example. After performing in MATLAB, this is how the image will look. Let's say this is the input image. After I perform a negative transformation on this image using the above formula, this is the output that I am going to get. So basically this transform does what? It enhances white or gray detail embedded in the darker region. This is the purpose of this transform. So let's do a basic numerical to understand how this transformation is working. As I showed you that, let's suppose there is an image with 4 rows and 3 columns, 4 by 3 image. This is the image. Here L is equals to 2 raised to power BPP. BPP is 3, which is given here. We can also understand by looking at the image what is the BPP. But for now, let's assume that it is given. So L is 8. Hence, we start making a table here. So these are the values for the current pixels. These are the possible values for the current pixels, and we calculate the transform image negative transform by application of the formula S is equals to L minus 1 minus R. So L here is 7. L here is 8, L minus 1 becomes 7. So 7 minus the current pixel value, which here it is 0, becomes 7. Similarly for here, L minus, since the formula has become 7 minus R, so 7 minus 1, basically, which that is 6. For the pixel value 2, again the formula remains the same, basically 7 minus 2, which will become 5 here. Again, this is 7 minus 3, which is 4. So 7 minus 4 again is 3, 7 minus 5 is 2, 7 minus 6 is 1, 7 minus 0 is 0. So as you see, it is reversing the value. The darkest pixel, that is 0, is becoming the brightest pixel 7, and the brightest pixel 7 is becoming the darkest pixel 0. So here, this is the final table that I showed you, and this is the output image. So how to create the output image? Looking at the input image, we are going to see this is the given image. Here this is the value 7 for the given image. This pixel has value 7, but the now new calculated value is 0. So here we are going to put this value as 0. In the previous slide, you see the given value here for the pixel is 6, and the new computed value we are going to put it as 1. Similarly for all the pixels we are going to do, and this is going to be the output image that we are going to receive. So this is how we apply your basic image negative transform. Now this is the graph of image negative transform. So the graph starts with the 0, because the values of in the image starts with the 0, and it ends with L minus 1. Since here we already said that the DPP is 3, so L minus 1 is 7. Again, the graph terminates on y-axis also on L minus 1. And if you plot the graph with the same values which are showed in this table that we just created using the formula, you will get the graph like this. Basically, this graph is representing that we are inversing the original pixel values to get a new pixel value, and the new pixel values are exactly inverse of the original pixel values. So the darkest pixel is becoming the brightest pixel. So darker pixel is becoming, this is the darkest pixel, it is becoming the brightest pixel, and the brightest pixel is becoming the darkest pixel, and similarly all the pixels are inversed. So very basic, simple image negative transform. I hope this made your concepts more clear. Thank you.